Today's webinar, Enabling Inkjet Printing on Polyethylene and Polypropylene. This is Mark Plantier, Enercon's Vice President of Marketing, and we're looking forward to bringing you some insightful information from our expert panel today. Before we begin, we want to let you know that today's webinar is being recorded and will be made available to all registrants within a few days. You may ask a question at any time during the webinar by typing it into the question tool provided on your screen. Our panelists will answer questions at the end of the webinar. Today's presentation, Enabling Inkjet Printing on Polyethylene and Polypropylene, will bring you up to date on the implementation of the latest inkjet technologies and how surface treatment is enabling and improving adhesion on a wide range of applications. We are fortunate today to have two very knowledgeable presenters. Jim Miller is Sales Manager and Vice President of Paul Leibinger Incorporated. Leibinger is a leader in inkjet printing technology. Jim holds a degree in industrial engineering and has over 25 years of experience in marking and coding solutions. Ryan Schilke is Enercon's Vice President of Sales and has nearly 20 years of experience in the packaging and industrial industries. Ryan's passion for innovation and customer success is a driving force behind Enercon's plasma and flame surface treating solutions. Let's begin with a summary of the information that will be provided in today's webinar. Our panelists will cover the benefits of digital inkjet printing, from digital flexibility to equipment improvements, including sealed nozzle technology. They'll cover why some surfaces are difficult to bond with, ink chemistries that can overcome adhesion challenges, including a review of diverse industry applications. We'll look at how inline surface treatment improves adhesion and how companies are using surface treatment to improve quality and output. And we'll wrap up with a question-answer session at the conclusion of the webinar. To get things started, I'd like to hand it over to Jim Miller, who will bring us up to date on the benefits of today's inkjet printing technologies.
Thanks, Mark. Inkjet printing is a digital technology. Continuous inkjet is the type of systems we're talking about. Again, it gives you the flexibility to print text with customizable fonts, which can be important as far as QR and QC wanting to have the fonts match what you're used to seeing. The barcoding is getting more popular and more in demand. The 1D codes, 2D data matrix, and QR code. You can create graphics and logos and print those along with all the other information. Variable data, which is difficult to do with any kind of fixed contact coding, dates, times, shift codes, serial numbers, etc. And then we have the ability to also accept external data. You can have a unique code on each product where the information would be read from a record of a database, and that can be sent into the printers through Ethernet connections, serial, or by a database that's saved on a USB stick with no external PC or network. At Leibinger, we use our sealed nozzle technology, which makes the use of inkjet very easy. It's ready when needed. This is something that has always been a bit of an issue with continuous inkjet printers, is their reliability, how easy they are to restart after long-term shutdowns, how easy they are to operate. Our systems use a true Windows CE interface for very simple operation from the standalone touchscreen or to integrate into a network. We've also built systems that are have limited maintenance requirements. There's really no daily, weekly, or monthly service or intervention or cleaning required, which is, again, something unusual in the world of inkjet printers. The printers will run unattended for many months as long as the install and operation is done correctly. And our preventative maintenance is very easy. It's low cost, no modules to replace, easy to perform, and only required once or twice each year depending on the ink type that you're using. Again, we've built our machines with economy of use in mind, and the biggest cost savings is in the reduction in downtime on your production line. The hydraulic design is also very efficient for low solvent consumption, low consumption of inks depending on nozzle types that are chosen, and we even have some options to further reduce the solvent consumption with our EcoSolve.
All right, thanks, Jim. Ryan will now cover why some surfaces are difficult to bond with.
Thanks, Mark. One of the questions that we get fairly often is, what are the adhesion impediments that are found on plastic surfaces? By and large, most plastics tend to have what we call a low surface energy. You see that kind of by the guy yawning on the left-hand side. But there are a few other things that tend to go along with adhesion problems. One might be surface contamination. This could be anything from dust on the material after it's been extruded or molded, that it's sat around for a while. You could have additives in your plastic which migrate to the surface. This can and sometimes is a surprising challenge to folks that they find. Also, inherently, there are a limited number of bonding sites for your ink to adhere. When you combine all these components, what you end up with is a surface that tends to be hydrophobic. So as we talk about a little bit about adhesion, it's important that we also talk about adhesion. So low surface energy, a lack of bonding sites, and surface contamination all have a negative impact on adhesion of ink, and ultimately they fail to wet out to the surface. What you're seeing in this image is just that happening. Droplets of ink are staying on top of the plastic surface here, and they're not wetting out, which ultimately will lead to inadequate print adhesion. So the force of cohesion is that the force of something trying to stay together. The force of adhesion, two things trying to stick together. And without proper surface treatment, without proper surface energy, with certain ink combinations, what you get is the force of cohesion being greater than the force of adhesion, ultimately leading to improper ink adhesion.
All right, thank you, Ryan. Jim, can you talk a little bit about how ink chemistries can sometimes overcome these surface adhesion challenges?
Sure, Mark. There are certain, quite a few materials that inks have been developed for that will provide satisfactory adhesion of the ink. In some of these cases, wire and cable, pipe and tubing, electronics, automotive parts. For many of these cases, we have inks that are available that will work satisfactorily. There are also instances in these same industries where we don't have inks that really perform to what typically are your expectations. But some of the industries that we do have inks that do extremely well, and some specialty inks in the food canning. We have inks that fade-resistant inks through the retort process. Also inks that are thermochromic, in that they print black, and once they go through the process, they turn red or blue to indicate that that process was completed. Again, that ink is specifically formulated to adhere to that can and make it through the entire process. Extruded cable, pipes and tubes, PVC, we have inks formulated that adhere very well and also resist the transfer when coiled, which is an issue that we can have with PVC materials. Again, the HDPE, the PE, and polypropylene typically are very difficult to find any type of ink that is really acceptable. We have some that are better than others, but we'll talk more about what the surface treating can do for that. We have chemical resistant inks, inks that are resistant to isopropyl alcohol. We also have one specific ink, certified by Boeing that is Skydrol resistant, which is one of the tougher chemicals to be resistant to. Again, some other unique applications where inks are developed specifically to adhere and to work properly. We have actually edible FDA food grade inks for printing onto food products or onto pills, pharmaceuticals, and so forth. We have a special white pigmented ink for printing directly onto silicon rubber that performs very well. Security inks are getting to be more popular for many industries to track information on products. We have orange, magenta, that print clear and fluoresce under UV light. These ink types that we use in the printers, there's typically 3 different bases. MEK is by far the most popular and the most economical, typically. We have straight ethanol-based inks, slower drying, lower adhesion properties, typically on plastics. And then we have a acetone ethanol mix, which are getting considerably more popular. They're very low VOC content, but still have very fast dry times. And then the specialty inks that are specifically formulated for very unique applications. And of these ink bases, then we have we further break down how inks are categorized, whether they're a dye-based ink, again, which has a large number of formulations, but provides very low contrast, typically on dark materials. We have soft pigmented inks, which are better contrast and run in a standard inkjet printer. And then we have the pigmented or the heavy pigmented high contrast inks, which will give very good contrast on dark materials. And again, some of the specialty inks and applications that we do have inks for that typically don't require treating. The PVC, no transfer inks. We do have a UV cured ink that again makes the ink very chemically resistant, but doesn't necessarily mean that it will be adhering better to the material. So in that case, it may need UV curing and a treatment, surface treatment. The clear UV fluorescent security inks, the thermochromic inks. We have special inks specifically for glass. And then we have some people who really actually want the ink to wash off, which is the opposite of why we're here today. They want to print the ink and then have it wash off either in a process or in some parts with returnable bottles and water bottles and so forth.
Thanks, Jim. Ryan, can you talk about how inline surface treatment enables ink adhesion on some of these more difficult surfaces?
Yeah, Mark, we talked earlier about adhesion impediments. So a quick review, most plastics, particularly polyethylenes and polypropylenes, have a low surface energy. You can often find contamination on the surface. Additives can migrate to the surface and limit the bonding sites. All of those pieces can lead to adhesion impediments. So as we go through and transform a surface by surface treating or plasma treating, essentially what we're looking to do is we're looking to create a high energy, maybe a little disco move on the surface there. We eliminate contamination or minimize contamination on the surface. Those additives that migrate to the surface, we're able to remove those, and we're also able to increase the number of bonding sites. All of these things contribute to turn a surface that was hydrophobic into one that is hydrophilic and will ultimately better accept the ink that you're laying down. So I mentioned on the last slide a little bit about surface treating or plasma treating. Oftentimes we'll get the question, what is plasma? And simply explained, plasma is an ionized gas. In most applications that we look, particularly in printing, we're typically ionizing air. So those charged ions and energetic electrons, generally those being in equilibrium, we generate that by ionizing simply the air around it. There are some applications which are a bit more difficult to treat, where we may blend in a a chemical mixture of gas to help promote adhesion in those applications. So plasma treating is going to remove both organic and inorganic materials from the surface. We talked about etching, and really what we're talking about is a micro etching. It's not something that you're going to be able to see with the naked eye. Our goal is to not modify the surface in a way that it takes away from the look and feel of your product. But what we do in micro etching is we're creating more bonding sites for the ink to adhere to. And finally, we're also going to functionalize the surface by increasing the number of polar groups on the surface, again, ultimately leading to better ink adhesion. So what you see on this slide are two of our technologies that we use for enhancing the surface energy. The picture on the left shows what we call our blow and arc discharge, and this is going to be particularly set for some applications. We are generating this arc in about a 2.5 inch or maybe a little bit wider arc or treatment area, so we're able to get a fairly wide area of a product to allow you to print on it. Typically, this technology is going to be used in a little bit slower applications, typically inline. We'll talk a little bit more about that. But what we're looking at is about applications that would run 30 feet per minute. On the right side, we're looking at what we call our blow and ion technology. And instead of generating that big purple arc like you see on the left on the outside, we're generating it on the inside here. And through compressed air, blowing the ions out, that will clean the surface, functionalize, and etch the surface itself. These are used, you're typically looking at about a 1/2 inch width on these treatment areas. Can go a little bit higher, a little bit narrower, but that's typically where we're looking at there. And it's going to be used in high-speed applications, as well as this can be used on both conductive and non-conductive materials. So what do we see? How do we measure results? How do we measure success? One way that we can look at is we can look at dyne levels. And dyne levels will typically give us a pretty good indication of where a material starts and where it goes after treatment. Dyne levels don't always translate into acceptable ink adhesion, but they're usually a pretty good indicator. On polyethylenes, you typically start somewhere in the 32 to 34 range, and we increase those to 42 to 60. Polypropylenes could start a little bit lower, but still 30 to 34 dynes, end up 45 to 60. Once you cross that threshold of 40, 42, you're typically going to see pretty strong ink adhesion in applications. So what you see in the two pictures here is you're going to see the results both before and after. So the top image is untreated. An ink droplet's laid down on a plastic surface. It tends to bead up, much like water on a freshly waxed car. It's going to bead up and not adhere to the surface. Second image down shows that ink droplet flattening out, or wetting out as we will call it. And that is typically a good indicator of what will lead to acceptable ink adhesion. The bottom picture just illustrates this with more droplets. On the upper right-hand side of that picture, you see a number of droplets that aren't wetting out. The bottom side of that picture is treated, and you see that ink lying flat across the surface. So Jim talked a little bit about there are times when you don't need surface treatment, and there are inks that will work. But when should you consider surface treating? If you're seeing unacceptable ink adhesion on your product, and this may be, maybe it's scratching off, maybe you're providing a tape test, maybe whatever test that you're using to test the durability of your ink, the adhesion of your ink, that's when you really want to start thinking about surface treating in your process. If you're getting inconsistent ink adhesion, another good indicator. Or generally, if you're just looking and have a desire to improve the quality or maybe even the output of your systems. All good reasons to consider surface treatment into your process. So we talk about this. We've seen a few pictures of what the plasma looks like. How do you integrate this? There are really two ways of doing this. And in many printing applications, it tends to be the first one. It's a fixed treatment location. Usually in continuous inkjet applications, we're fixing not only the inkjet head itself, but we're also fixing the plasma treater in a specific position, and parts are being conveyed down the line on some sort of conveyor belt typically. We also have cases where someone wants to move the treater head, or likewise could really move the part, and this could be done robotically in some way, shape, or form, or some sort of indexing system as well. We can work with your application really in any way that you'd like to look at integrating the system.
Thank you, Ryan. So to recap, we looked at the flexibility that inkjet technology can offer through digital printing. We've seen some of the new improvements made to inkjet printers that are low maintenance and easier to operate than ever before. We took a look at adhesion impediments and specifically polyethylenes and polypropylenes and how they are often difficult to bond with. We reviewed ink chemistries, which can be used for very specific applications. And we talked about how plasma treatment can improve adhesion, both for those situations where the ink is not adhering at all, in situations where the ink is not adhering in a durable enough fashion, as well as the plasma treating basically improving overall product quality by enabling adhesion and wettability of all types of inks. Both Jim and Ryan welcome any questions you may want to throw out to us right now. They are also available after the webinar through their contact information that you see below. We're going to begin addressing questions. Looks like we have a number coming through already. The first question is for Jim, and the question is, what is the typical durability of ink on HDPE?
Typically on untreated HDPE, we'll see that the ink might survive a real basic rub test, but typically even a tape test where a tape is laid across the ink is going to pretty much lift most of the ink off. So it's average to poor in general on untreated PE.
All right. Ryan, here's a question. How long does surface treatment typically last before the surface returns back to normal conditions?
Thanks, Mark. That's a good question, and it really varies from application to application. We will see it sometimes last 4 months, sometimes days, sometimes it can last for minutes. So what we will typically do is we typically recommend to our customers that they treat immediately prior to printing or whatever their application may be.
Ryan, what technology is used to ionize the air gas to create the plasma?
That's a good question, Mark. The technology used to ionize the air and gas is if you're familiar with corona treating at all, that's used in the printing and converting industries on flexible materials. We're really looking at doing the same things. What we're doing is we are passing a high voltage electrical discharge across an electrode or a couple of electrodes. That generates that discharge, whether it is the blown arc that we showed in the presentation or the blow-on ion. It's just a matter of then how that discharge is blown across the surface that we're looking to treat.
Thanks, Ryan. Here's another question for Jim. Do the printers require plant air to operate?
No, our printers operate strictly on 110 volt AC power, very low power consumption. The plant air is not required to actually operate the printer. We do recommend, and the printers have the air lines built in to pressurize the print heads with plant air when we're in very dusty environments or in wet or wash down environments to help keep more contamination out of the print head.
Thanks, Jim. Ryan, is this technology limited to plastics, or can it be applied to other materials such as foils or materials used to produce labels?
Yeah, the plasma treating technology can be used across any number of materials. It can be used on plastics. It can be used on metals itself. What we have to look at in that case is just making sure we apply the right technology to that application.
Jim, how close do the print heads need to be to the material?
Typically, we're about 10 millimeters is a good average. That can vary, though, from a millimeter up to 50 millimeters, depending on what's printed, what the material production speed is. Typically, the faster we run, the closer we want the print head to be. When we're up in the 1,000 to 1,500 feet per minute range, we're typically very close. For larger fonts, slower moving materials, if you want larger print, we may be up to 2 inches away.
Very good. Ryan, does etching have an effect on the dielectric of wires used in the wiring cable industry?
Typically, our experience has been no, that it doesn't, that we are able to safely treat the jacketing on wires to allow you to get better print adhesion on those. Most of what we see in that part of the industry is typically our blown ion, just from the fact that we're generally dealing with a smaller diameter that we need to print on.
Jim, is there any possibility to print on textile garments with inkjet?
Yes. Again, we're non-contact. We're throwing the ink at the material, basically. Depending on the material, how porous, and what kind of resolution you need to see, it's something that we have done in the past, and certainly with any product or any process like that, we're always willing to do sample testing in our labs.
Ryan, besides ink adhesion, what other adhesion improvements have plasmas been used for?
Yeah, we've kind of concentrated on ink adhesion in this webinar specifically, but there are a lot of other applications. Adhesive applications for glues, it's a big part of what we do. Potting applications is another area where we do quite a bit. Really, any piece where you're trying to bond two objects together, adhere two objects together, is probably a good application for plasma treating. And anything you've got, you can talk to our team, and we do have a full-time sample lab here which we can run trials and help you experiment out on that.
Another question here on inkjet technology being used on glass bottles in the cosmetic industry.
Yes, there are inks available specifically for glass. Again, the cosmetic industry, we typically recommend and typically test using one of the isopropyl alcohol resistant inks due to the amount of alcohol used in the cosmetics.
Ryan, what is the temperature of the plasma arc?
Good question, Mark. Typically what we'll do is we don't look at the temperature of the arc as much as what we're looking at doing is making sure that we're able to process the material under our arc, whether it be a blown arc system, a blown ion system, and verify that we can pass that product through the plasma without damaging it at all. Our goal is not to change the look or feel, given that's what most of our clients are looking for.
Ryan, we talked mostly about plasma treatment today, but Enercon does offer flame treatment, and we have a question here regarding the advantage or how you would compare plasma and flame treatment.
Plasma and flame by and large, are ultimately working towards doing the same thing for you, looking to increase adhesion on whatever your application is. Plasma tends to be used, blown arc plasma can be used on non-conductive materials. Blown ion technology can be used on both conductive and non-conductive materials, so metal and non-metal objects. And those are typically defined into specific widths. When you get into a flame plasma technology, what is ultimately different is, again, you can do both conductive and non-conductive materials, but we've got more variation on width. We're using propane or natural gas in that process, and we're able to build treatment heads for those applications anywhere from 2 inches, about 50 millimeters, on up into 8, 10, 12 inches wide. So we're really able to get a much wider treatment area with flame treatment, but ultimately it accomplishes the same thing.
Jim, what experience do you have with inks and PTFE?
Well, I think we've tried inks on pretty much every material. What we tend to find with plastics is whether it's PTFE or PE or polypropylene, that it really varies from one manufacturer to another or one formulation to another. There can be very subtle differences in some, I believe, some of the additives, as Ryan had mentioned, that really affect the properties. And typically on these we start with our MEK-based inks and almost always do testing to see where we come up with the best solution.
Thanks, Jim. Ryan, how fast can a plasma treater be used on wire prior to printing?
In wire printing applications, we've actually run really quite fast, a few hundred meters per minute in many cases. We'll typically use our blown ion systems for these. If one head isn't sufficient, if we're not getting sufficient speed, we are able to add multiple heads to create faster and faster line speeds.
How is plasma treatment with air different than corona treatment?
Good question, Mark. Plasma treatment and corona treatment, oftentimes those terms can be interchanged, and we often use them interchangeably. In the treatment of objects, they're quite often interchanged. And what we are doing in many applications is using a kind of a base of corona treating, and the fact that we've got an electrical discharge that is ionizing air, that is kind of a corona treatment. When you also bring in other gases, inert gases into the mix, that may sometimes be more often referred to as plasma treatment in some circles.
Thanks, Ryan. In your experience, are there any problems using inkjet technology on PET bottles, and is treatment ever required?
From our experience, no. PET is actually one of the plastics that's more accepting of ink. We typically have some of our more standard generic inks that work extremely well on PET, and typically is not an issue and does not typically require any treatment.
Ryan, does the plasma process have any negative quality issues to previously silk-screened or decorated plastic components?
That's a good question. It may or may not. Our goal ultimately in plasma treating is to not affect the surface, not change what your product looks like on the outside. Most often we're doing applications before decorating or before silk screening. So that would be one we'd definitely want to reach out, run some tests in our lab, treat the objects after they've been printed, and see what the results look like for you.
What's the dwell time for a blow-molded HDPE bottle under the flame or plasma treating to properly treat for a coating date printing?
Well, the amount of dwell time is going to change from application to application. It is, I'll say, typically pretty quick. As fast as you're moving bottles down the line, we will typically be able to keep up with whatever that speed is.
Are there standalone systems that are totally self-contained and can be easily put in with existing machines, or lines, I should say?
I think the answer probably from both Jim and I are yes. Yeah.
Right.
Jim, are there custom colors available?
We have a wide range of colors in our standard ink library. Typically, to develop an ink with a specific color for CIJ printing, again, the inks are formulated and have conductivity values and properties. So inks are typically formulated specifically for a manufacturer's machine. It can be done depending, again, from our standpoint, again, on the volume. It takes approximately anywhere from 6 to 12 months to develop and fully test an ink, and it may be something very similar to what we've used, but our experience shows that even changing one small component in an ink, whether it's one of the dyes or one of the resins or the solvent, can have a very adverse effect on the running properties. So we can do it potentially, but typically customers go with one of our existing colors.
Thanks, Jim. Looks like we've got time for about 1 or 2 more questions here. Again, if we do not get to your question during the live webinar, our experts will follow up with you afterwards. Regarding plasma treatment of containers and bottles, is there a suggested wall thickness for a plastic container to receive plasma treatment?
No, not in particular. We're able to typically work with any wall thickness, whether it be a thicker bottle or as bottles thin out today. Typically, we can work with any surface that you bring us, whether it be thick or thin.
Does the color of the ink make a difference regarding the adhesion to the plastic?
Not necessarily the color, but just the entire formula of the ink can have a very different effect depending on what the material is.
Well, thank you, Jim. Thank you, Ryan. And I'd like to thank everyone who stayed online for our question and answer session. Again, everyone will be receiving an email which will include a link to download a recording of this presentation and the presentation slides. You should receive that in the next 24 to 48 hours. You'll also receive contact information for both Jim and Ryan. And once again, we'd like to thank you again for your participation today. We hope we've been able to help you get a better understanding of inkjet printing, difficult surfaces, and surface treating. Once again, thank you very much. This will conclude the webinar.